Hello everyone, welcome to my channel. Let's learn computer science. Okay, so in last session, we started to learn about conversions from one number system to another, right? So we'll quickly give you a syllabus reference. Um, so convert an integer value from one number base representation to another. So that is what we started to learn, right? Now, in last session, we have covered about binary to decimal and also how to convert a decimal to binary. In today's session, we are going to learn about binary to hexa and hexa to binary conversions, right? And then we'll cover hexa to denary and denary to hexa in next session. Okay, so very small session. Let's start uh, by taking a number and then we'll convert that number, uh, binary number to hexa number, right? So we have this number 101010001. Okay, this is a binary number as base is written here 2 and we have to convert it into hexadecimal number. Okay, very simple method, nothing to remember, just the simplest conversion so far. Okay, so whatever number you get, what you have to do, you have to make group of 4 bits starting from right hand side. Okay, so firstly make first group of 4 bits from right hand side and then next 4, and if you have next, then make group of next 4 bits. If in case you do not have enough bits, like you don't have 4 bits, then you just take all the bits whichsoever is left. Like if 3, then put a 0 at first place, or and you just make a group of those 3 bits only. Okay, so make a group of 4 bits. That's the first step, right? Make group of 4 bits from right to left. Okay, now remember in our session where we learned about number systems, I told you how to what is the equivalent of a binary to denary, from 0 to 15. So looking at that table, so I'll just show you that table also. Looking at that table, this one conversion table, just remember always this table. So this becomes very handy in all the conversions. So make this table on a rough page when you sit for an exam, or when you sit to solve past papers, or whenever you sit to practice these conversions. So make this table. This is very handy in all these conversions, right? So uh, where were we? Yeah. So first step is make group of 4 bits. Okay. Now for each individual group, look for the corresponding value, hexa value. Okay. So for this we have 9, or you can, if you remember how to convert, so you know that this is 8, right? And this is 1, and 8 plus 1 is 9. So 9 in hexa, we write it as 9 only. And here this is 10, and 10, we don't use 10 in hexa. Instead, in place of 10, we use A. So our answer is A9 in hexadecimal. Simple. Just repeating. Firstly, make group of 4 bits, right? We have created groups. Then look for these individual, look for the individual value for these groups, and then write all those digits together to make a hexadecimal number. Simple. Now, next is hexa to binary conversion. Okay, hexa to binary conversion. Now, for hexa to binary conversion, I have taken one more number here. in hexadecimal, and we are going to convert it into denary. Okay. Now, BA6, we will treat them as individual bits and we'll look for the individual equivalent binary number in the table that I have just shown you. So if you look here, so B is 1011, right? So if I go back, B is 1011. Now A is in that table. If I look in that table, A is 1010, right? This is A and this is 1010. So 1010, and 6 is 0110, right? You can look at the table also. So 6 is 0110, and that is what I have written here. For each individual bit, I have written group of 4 bits in binary. And finally, you write them together to make one complete binary number, which becomes your answer. So 1011, 1011, sorry, 1010 and 0110 is your final answer, which is written here. Simple. Yeah. So that's all for today. So in the syllabus, uh, where it is mentioned, convert the integer value to from one base number base to another, we have covered binary to denary, denary to binary, and today we have covered binary to hexa and hexa to binary. That's all for today. Thank you.